So let's talk a little bit about absolute extrema. If you have a function, say a cubic function, that looks like this, you have a local maximum and a local minimum. But you don't have an absolute maximum because this end continues to rise, or an absolute minimum because this end continues to fall. However, if we restrict our domain values to a certain range or interval, let's say between A and B, then in this case there is an absolute minimum and there is an absolute maximum. Now your absolute mins or maxes are going to occur when the first derivative is 0, or you have a horizontal tangent, or at these endpoints. So let's work a couple of these. I'm not going to do all of them because it's pretty repetitive, and it's just and there's several different types for you to do and practice. But basically, you're just going to take the derivative, set it equal to 0, find those values, check those values if they are in the interval that you're given, as well as the endpoints, and then you'll know if you have absolute extrema or not. So for this first function, f prime of x is 9x squared minus 6x minus 3. So it's never undefined. It exists everywhere. It's a nice polynomial curve. I'm going to take 9x squared minus 6x minus 3. I'm going to set that equal to 0. I'm going to factor out a 3. It will give me 3x squared minus 2x minus 1 equals 0. That will further factor as 3x and x and 1 and 1, a minus and a plus. Now, if you're not able to factor that, what you should do is you should use the quadratic formula. 3x plus 1 equals 0. 3x equals negative 1. X is negative 1/3. X minus 1 equals 0. X is 1. So I have these two critical values that I need to check if they're in the interval. So I look at my interval that's given negative 1 to 0, and I realize that positive 1 is outside that interval, so only negative 1/3. So I have three x values. X is negative 1/3, x is negative 1, and x is 0. So we have to check it at the critical value that is within the interval and at the endpoints of the interval. So we want to do these in the original function. Okay, so we've got our potential x values where extreme values, max or min, could occur. We don't know which one is what yet. So I need to find f of negative 1/3. I need to find f of negative 1 and f of 0. Okay? It doesn't matter which one you do first. I'll do the 0 first because that's the easiest one. 3 times 0 cubed minus 3 times 0 squared minus 3 times 0 plus 10. This gives me a 10. So f of 0 is 10. That's one of the values. Now I have to check the others to see which one is going to give me a maximum and which one is going to give me a minimum. So I'll do f of negative 1 next. F of minus 1 would be 3 minus 1 cubed minus 3 minus 1 squared minus 3 times minus 1 plus 10. So that gives me 3 times negative 1 minus 3 times 1 plus 3 plus 10. That's negative 3 minus 3 plus 3 plus 10. Negative 6 plus 3 plus 10 is 7. So f of negative 1 is 7. Now, between these two, this would be the maximum of 10 occurring at x equals 0, minimum of 7 occurring at negative 1. But we can't declare that until we look at what happens at negative 1/3. So the next thing I'm going to do is I'm going to do f of negative 1/3. And I'm going to use my calculator, my off-screen calculator on this because it has a fraction key. Equals 3 negative 1/3 cubed minus 3 negative 1/3 squared minus 3 negative 1/3 plus 10. Now you might want to just put it in the calculator just like that. I'm going to clean it up a little bit. 3 negative 1 over 27, because look, 3 times 3 is 9 times 3 is 27, minus 3 times 1/9, that's negative 1/3 squared, plus 1, because those cancel out, a minus and a minus make a plus 10. So that's negative 1/9 plus, nope, negative 1/9. So that's negative 1/9 minus 1/3, because that 3 goes into that 9, 3, plus 11. And I'm going to take out my calculator and just enter negative 1 fraction key 9, subtract 1 fraction key 3, plus 11. And it gives me 10 5/9. But they're going to want it as a fraction, so I'll press second fraction key, enter. That's 95 over 9. 95/9. Now look, that is 10 5/9, which is actually bigger than that. So the maximum occurs at negative 1/3, and it's 95 over 9. So 95/9 occurs at x equals negative 1 over 3. And the minimum, 7 is lower than these, so the minimum of 7 occurs at x equals negative 1. Now that's just within the interval from negative 1 to 0. Now you're going to repeat this process on all of these problems. Like number 2, same process. Make sure that your value is between negative 7 and 4. Same process here, between negative 5 and 5. So number 4 is slightly different since it's a rational function, so let's do this one. To find the derivative, we take the denominator, 8 plus x, times the derivative of the numerator, negative 1. Subtract from that the numerator, 3 minus x, times the derivative of the denominator, 1, over the denominator squared. Distributing this backwards, minus 8 minus x, and this one forward, minus 3 plus x. The x's will add to 0, so I have a negative 11 over an 8 plus x quantity squared. Now, both the original function and the derivative don't exist at negative 8, so x can't be negative 8, but we don't have to worry about that because they gave us an interval from 0 to 8, and negative 8 is way outside of that range. Now, there are no critical values for this function because since the denominator can never be 0, we would set the numerator equal to 0. But since it's a constant, there are no critical values. So if there's a max and a min, they would occur at one of these x values, x equals 0 or x equals 8. So one of them is going to be the max, the other is going to be the minimum, unless they happen to be the same, okay? Which I don't think is going to happen. So let's evaluate f at 0. That's going to give me 3 minus 0 over 8 plus 0, which is 3/8. And they've asked for 2 decimal places, so 3 divided by 8 is about 0.38. It's 375, but to 2 places is 0.38. And f of the other endpoint, 8, would be 3 minus 8 over 8 plus 8. That's going to be negative 5/16. That as a decimal is, to 2 places, negative 0.31. Now look, that one's obviously smaller than that one, so this is your max occurring at 0. That's x equals 0. This is your min occurring at x equals 8. So the absolute maximum just on this little interval from 0 to 8 is 0.38 occurring at x equals 0. And the absolute minimum is negative 0.31, and it occurs at x equals 8.